work on at the top. This just has a teeny tiny, just to relate this to you, we'll review from our quadratics unit. So I just have a little set of factors there. And I just realized that this should be x plus 3, as I was looking at that right there. But that is what we call factored form. And if we were to multiply it out, change that to a plus for me, I screwed that up. This would be what we would call standard form if we would multiply it out. Now, if you guys remember from our last unit, if it's in factored form, you can see the zeros really quick. I know this is not an equation, but if this was set equal to 0, my two answers would be -5 and +2. Whereas if I just see x squared plus 3x minus 10, I don't know what the answer is. I have to use like quadratic formula or factoring or completing the square, but I can't just see it from looking at that. But you can see the zeros or the answers right from looking at the factored form, because it's just what sets the little set of parentheses equal to 0. So we are going to practice just in this first example, writing out something that's a little bit more complicated in standard form. So basically, instead of just foiling two things together, we're going to do 3. This is not hard, I promise, but all you want to do, I just recommend just do 2 at a time. So, and if I'm multiplying these out, I usually choose, and it doesn't matter the order you do this in, but I usually choose to do the 2 on the end first. So I'm just gonna literally focus on that for a second. If you like a box, we can make a little box, or we could do a foil. It's totally up to you. But we're just gonna do 2 at a time. And then after I multiply those out, then I'll go back and multiply it by the third little set of parentheses. And you can do this in any order. The algebra might look a little different, but we should end up with the same answer. I just do the last 2, and I'll explain that in 1 second. I'm just going to do a little foil real quick. If I do x times 3x, we're going to get 3x squared. X times 4 is going to give me 4x, and then I'm going to multiply 5 by both terms. So 5 times 3x would be 15x. 5 times 4 is 20. And then most of the time, you're able to combine some like terms, and I can do that here, the 4x and the 15x. We can put those guys together. Those are like terms. That'd be 19x plus 20. And so I've multiplied those two together. Now, I'm just going to bring down this other factor. We have this x plus 10. And the reason I like to do the last 2 first is I like to put the one with the smaller number of terms first, if I can do that. So the binomial times the trinomial just makes it easier for me to do. Now, I'll show you that little thing I was doing yesterday. So I just go through, and I'm going to multiply everybody by x. And we're going to get 6 different terms here, but we'll hopefully save some space. Or if you want to draw a box, please feel free. We can draw a box on these too. So if I do x times 3x squared, it's going to give you 3x cubed. Each one of these, when you multiply by x, we're just going to add a power of x. All the coefficients should stay the same, just multiplying an x through here. So this would then be 19x squared and then 20x. All the coefficients would stay the same. Okay, now I got to also multiply everybody in there by 10. And if you remember from yesterday, I just kind of try to line up the like terms when I do this. So if I do 10 times 3x squared, I'm going to get 30x squared, and I just line that up underneath the other x squared term. If I do 10 times 19, some of these will be bigger numbers, so this would be 190x. It's okay if you get a huge number. And then 10 times 20 is 200. And just for me, lining them up in that format makes it easier to combine like terms. So I've got no other x cubed besides the 3x cubed, so that one's by itself. 19 and 30 are going to add up to 49x squared. 20 and 190 are going to add up to 210x's. And then just a 200, nothing to combine that with. So all multiplied out, that would be the standard form of that expression we started with at the top. It's not terrible, it's just kind of time consuming. Is anybody having a question? Okay, now, the other one I put on here, and the real reason I put it on here, is just to remind you of something. If I am squaring, this is x plus 4, and we're going to multiply that by x minus 2 squared. Please, don't forget, don't distribute a squared. Anytime you have adding or subtracting in the parentheses, you can't distribute that. you have to remember that if you square something, you're multiplying it by itself. So what that means is I want to write out that x minus 2 twice because it's got 2 of them. If you just distribute the exponent, you completely miss out on the middle term and it'll give you the wrong answer. And then this is completely up to you. Again, like I said, just do 2 at a time. So I just usually take and do like a little foil on the last 2. And you guys try this on your paper, and actually I'm going to draw a box on mine when I get done with this first part, but I'll just be quiet. You guys try it on your paper. Bless you. I just did a little box on mine just as another method for how you could multiply that out for the 2 by 3. I think I got it right. This is a little weird. The 4x squared and a negative 4x squared, I got one at each of those, so those would actually cancel out. And left over, I have an x cubed, nothing to combine that with. If you did the little box, these two guys, the negative 16x and the 4x, I could put together. So it'd be negative 12x, and then I had a plain 16. Is anybody getting anything different? I think I did it right. Okay. Is anybody having a question about multiplying those factors into standard form? So factored form has parentheses, standard form you get rid of the parentheses. Okay, now in our other example here, we're going to go backwards. So I'm going to give you the standard form, and you're going to see if you can write it in factored form. Okay, now, if you have these questions, if they have a number in common, if we just have an expression, I can't get rid of the number. We have to pull that out in front of our factors of our parentheses. So like in this first question, you guys are probably like, oh, all those are divisible by 3, and they are. But you can't just get rid of the 3. We have to have the 3 as part of our answer if we don't have an equation, because we use factor right here. So what I want you to look at, it says factor these completely. So as much as we can, we're going to factor these polynomials down here. What would you tell me? I already lied, or I told you the 3. Do the terms in this first polynomial, I've got 3x cubed minus 18x squared plus 24x, do they have anything in common besides just a 3? What do you think? X. Okay, so this is, we're going to pull, and I have to take the 3. You can't get rid of it if we don't have an equation. So I'm going to pull 3x out in front of all the other terms. It's like undoing a distributive property. Can anybody raise your hand and just tell me, like, what would you have left if you divided each of those terms by 3x? Like, what would I have left in the parentheses? If I take a 3x out, what would we have left over after doing that? What do you think? Perfect. X squared minus 6x plus 8. Okay, now, here's what we're going to do here. And not always, but a lot of the time. Whatever I have left might be something I could still factor. So I'm just looking at what I have inside the parentheses here. Can you guys think, just ignore the 3x out in front for a second. Can you think of 2 numbers that if you multiplied them, you get positive 8, the same 2 numbers, you would add them, and it would give you negative 6? What do you think? Yes, okay. So negative 4 times negative 2 gives you positive 8. Negative 4 plus negative 2 gives you negative 6. So I can factor what I have my little highlighter on just a little bit further. We got to keep the 3x out in front, but we can factor this x minus 4, x minus 2. And it does. You can put the x minus 2 first or the x minus 4 first. It doesn't matter the order you put them in. But we can factor that quadratic just a little bit. So this is going into these two here. And then this is what we called the completely factored form. We had a greatest common factor we pulled out in front, and we had that quadratic, and we could go a little bit further with it. So we're going to factor it as much as possible. The better you factor it, or as long as you get it down, this makes it easier to solve if you actually have an equation. Okay, so let me look at part B here. I've got 2x to the fourth minus 50x squared. Do those two terms have any numbers and or variables in common? What do you think? 2x squared, perfect. All right. Now, again, you can't get rid of the 2 because we don't have an equation. We got to pull that out in front. So 2x squared. What would you have left over if you divided a 2x squared out of each of those terms? What would be left? What do you think? Perfect. Okay, x squared minus 49. Now, I know it's been a minute since we've done this too. Oh, why did I write 49? Forgive. All right, so 2x squared, x squared minus 25. Okay, now, it's been a minute. I don't know if you guys remember doing this. This is called a difference of squares. So, can you think of, for that, two numbers, if I multiplied them, I'd get negative 25, but if I added them, I don't have a b value in there, right? So it would add up to 0. So can you think of two numbers, multiply to get negative 25, add to get 0? Yes, negative 5, positive 5. It ends up, this is called a difference of squares because it ends up just being the square root of that number. So I can go a little bit further here, and we can write this as x minus 5, x plus 5. And again, the order doesn't matter. The x plus 5 could come first, the x minus 5 could come second. That totally doesn't matter. If you do have a greatest common factor, like I have that 2x to the second, that usually goes in front of any sets of parentheses if you're going to see that written properly. So if you just have something that's not in parentheses, you can go ahead and put that in front of any of the factors that are in parentheses. All right, now, the last one, I'm not going to lie to you, this one's kind of tricky. So this is going to be, we're going to have a number in front of our x squared when we pull something out. So these guys, the biggest number that goes into all of them is 2. They're all even. And I have at least how many x's in each one of these? X to the what? I have at least x squared, right? Do you guys see that? This is x to the fourth, x to the third, x squared. I have at least x squared in each one of these. So I'm going to divide everybody by 2x squared. All right, when you pull that out in front, we're going to have 3x squared plus 20x and then minus 7. And it's been a minute since we've done anything with this, and probably a lot of these, if we were solving a quadratic, I would probably just use the quadratic formula because it's a little bit faster for me. But for this scenario, we want to put this in factored form. Okay, so I'm going to remind you how to do this. We are going to multiply a times c. That's true for the other two questions that we just did. It's just that the a value was 1. So for this one, the a value is 3. So we're going to do 3 times negative 7. So that's negative 21. And I'm still going to add to get the b value, which is 20. Can you guys think of two numbers when you... Actually, hang on. Let me just write this out. So I got the 2x squared. If you remember this, I call this the Berry method. That's what the guy that developed it. So when you do this method, you take that first term, which is 3x squared, and you put that with no squared on it at the beginning of each of the factors. That's the main thing people forget. Just take that first term, drop the squared. I got to put that at the beginning of each of my factors. And we're going to fill them in with the two numbers that fit these requirements. Can you guys think of two numbers you could multiply together? They would give you negative 21 when you multiplied them, but when you added them, it would be 20. Yes, okay. So 21 times negative 1, right? That'd be negative 21. 21 plus a negative 1 would give me 20. So just in one of the factors, I'm going to put plus 21. In one of the factors, I'm going to put minus 1. Now that does not multiply back to give me what I have my highlighter on there. So one or both of the factors won't be correct, and you just determine that if they have anything in common. So I wrote that 3x plus 21 first. That is not the real factor because both of those are divisible by 3. Now, it's just a trick to the method. You don't pull that out in front, you just disappear that 3 out. The real factor there would be x plus 7. And then the 3x and the 1 don't have anything in common, so we're just going to keep that how it is. That would be our completely factored form. We can't go any farther than that. Does anybody have a question? That's the way the method works. And honestly, it would work here too. Like I would just put like x squared, just drop the square and put that at the beginning of each of the factors. It's just if your a value is 1, those will just automatically be the real factors in both cases. So it's just how the method, the guy developed the method. So like if this started with 2x squared, I would put 2x and 2x there. Good question. Does anybody else have a question? Okay, now, at the very bottom, we're going to solve some equations on the back of this in a second, but I want to talk to you about what we call a multiple zero or a multiplicity. Now, we did this with quadratics. We solved quadratics, and so it says here, the zero, if you guys remember, there's a couple different ways this can look. If you're just doing the algebra, 0 is the value of the independent variable, so your independent variable is typically x, and a couple of the problems we had for the quadratics, we'd have like time and height, so the time would be the independent variable, but it's basically the number I can plug in something for. So independent variable, the value of that would make your equation equal to 0, all right? And graphically, it's where the graph crosses the x-axis. If it's real, if it's imaginary, you can't see it on a graph. But then the third thing down here, this is super important. Okay. The number of zeros, or the number of answers or solutions or whatever you want to call it, the number of zeros is going to match the degree of the polynomial. So if I have a quadratic, I should have 2 answers. If I have a cubic, I should have 3 answers. If I have a quartic, I should have 4 answers. And you're probably thinking back to a couple problems we did with the quadratics where we just had 1 answer, maybe. And that's what I'm going to talk about to the side here for just a second. A multiple zero, we're going to get into this more on the back. This is not a technical definition. This is how I'm going to describe this to you. A multiple zero counts as more than 1 0. And this will make so much more in a second. We're going to do this on the back. I'll show you what this looks like in an equation. What we call a multiple zero, it basically counts more than once. And the number of times that it counts is called its multiplicity. So the multiplicity is, you're going to see this on the back, it is an exponent on a 0. And we're going to talk about that in, just like I said. But basically, it's going to be an exponent on your 0. So it's going to be outside of parentheses, or it can be on an x, and just a plain x, but we're going to see that on the back. Okay, now, these guys on the back are all going to be equations. If you guys remember doing this from quadratics, if I have 2 things or 3 things or whatever multiplied together to give me 0, then either the first thing is 0 or the second thing is 0. So if I tell you, I have a little factor right here, 3x minus 2, what would the 0 be? Like, what would you plug in for x to make that equal to 0? And if you want, you can actually do like 3x minus 2, set that equal to 0 and solve it. What would you plug into 3x minus 2 to make that 0? It's a fraction. What do we think? If I set that equal to 0, right? What do you think? 2/3, that's it. Done. That's one of your answers. Okay. What would I plug in? Don't worry about the exponent for the second. What would I plug in to x plus 2 to make that 0? -2. It's a little bit easier when you don't have a number with the x. Okay, now the deal is, if you have an exponent on that little factor, like I have a 4th power there, that means that 0 counts that many times. So this the negative 2 would have a multiplicity of 4. So basically that 0 counts 4 times. I know that doesn't make a lot of sense. When we get into the graphing and you guys see how this looks on the graph, it'll make more sense. But for right now, that question has 2 zeros, but one of them counts 4 times. All right, what would you plug into 2x plus 5 to make that equal to 0? What do you think? 5 over 2. It would be negative 5 over 2, so that way we would have that. Okay, no multiplicity there. What would you plug into x plus 6? Okay, you guys are frightening me. All right, so negative 6. Now, if it has a little exponent, this one does, and it's outside the parentheses, right? If this has an exponent, that means that that one counts that many times. So this has a multiplicity of 3. So that just means it counts 3 times. All right, what would you plug into x minus 7? 7, done. And that one also, if it has an exponent, then it has a multiplicity. So that one would count twice. So this has a multiplicity of 2. And the multiplicity just matches the little exponent. You don't have to do anything crazy. All right, now, this is very tricky. What would you plug into negative 2x squared? So no parentheses there. I just have negative 2x squared. What would I plug into that? Just 0. Just 0. If you're ever not sure, just literally copy, like if I did 2x squared equals 0 and I solved that equation, the only thing that's going to make that true is going to be 0 to plug in for the x. Now, this is tricky. This is not in parentheses, but the x is squared, so that does have a multiplicity. And that's the only time you're going to see it not outside the parentheses is if you just have an x and it has an exponent. It can't have a number in front of it like it does here, but this would count twice. So that has a multiplicity of 2. All right, now my next set of parentheses is actually super tricky. So I have x squared minus 64. What would set that equal to 0? 8 and... So this, like in the parentheses there, that's x squared, right? So that's got to have 2 answers. So he told me 8. What's the other answer? Negative 8. Okay, this, I know that's super weird, but this is actually, there's no multiplicity there. There's no multiplicity because the squared is within the parentheses. It's not outside, so there's no multiplicity. But if you guys are ever not sure, let me grab a different color here so I don't do this. So this should have 2 answers because it's x squared minus 64. If I come over here real quick, if I do x squared minus 64 and I set that equal to 0, because that's what you're doing there. If I add 64, to solve that, I have to introduce a square root. And if I introduce the square root, that's what introduces the 2 answers because they get plus or minus 8. So no multiplicity on that. But if I've got an x squared in the parentheses, that's got to have 2 answers inside there. And then the one on the end is just an x plus 5. So that would just be negative 5. And there's no multiplicity on that because there's no exponent on the parentheses. Does anybody have a question? All right, now, what I'm going to do in the next example is go backwards, and I'm going to give you the 0, and you're going to give me the little set of parentheses that would go with that. All right, so this says write a polynomial just in factored form, so we're just going to do the factors with the given zeros. All right, so if 4 is my answer, what would be the little set of parentheses that would go with that? If I just have 4, like I would have, what set of parentheses would have 4 as a 0? Exactly, x minus 4. Like if I plugged in 4 there, that would make that 0, right? What if I had negative 3? X plus 3, exactly, good. What if I had 2? X minus 2, yeah, whatever. If it's a positive 0, then in the factor you'll have subtraction. If it's negative for the 0, then you'll have positive, because we're doing like opposites here. Okay, the next one is kind of, I'm going to just kind of come below this a little bit. What if I just told you one of the zeros was 0? Like, how would I represent that? Just an x, exactly, just an x. So if 0 is one of your answers, you just put an x. All right, So if we have positive 3, the x minus 3 would be the factor. What about, this is always hard, what if I have a fraction? What if I have 2/5? How would I write that as a little set of parentheses? Like, kind of think backwards in your head. So like, if I were to get that answer, I would have to add 2 and divide by 5. So if I worked that backwards, what would that factor look like? Exactly. 5x, no, it's got to be minus. It's got to be minus. 5x minus 2. Because if it's a positive 0, then you got to have a minus in the factor. So that should be 5x minus 2. So then I would add 2 divided by 5. If you've got a fraction, just to help you with that, the denominator gets multiplied by x, and the numerator, in this case, if it's a positive number, you're going to subtract from the term with the x. If it's a negative number, you would add it to the term with the x if you're having trouble with the fraction. Okay, so we're going to try another fraction. What if I had negative 1/2? How would I write that into a little linear factor? What would the little parentheses look like if I had negative 1/2? Perfect. So it'd be 2x plus 1. Okay, now, how would I write 3 with a multiplicity of 2? Exactly. X minus 3, and then just if it gives you a multiplicity, just put that number as an exponent. So that would be like that. Perfect. Does anybody have a question? Okay. Now, we're going to solve these guys at the bottom real quick here. This is not hard, but we're going to have to factor to get there. You can't just look at these. Well, some of them you could get maybe one of the answers, because I think every one of them has 0 as an answer. But I want to make a little point to you here. Whatever the degree is, so the degree is the highest power of your variable. So my first little question there, I've got x to the 6. This should have 6 answers or 6 zeros or 6 roots or whatever you want to call them. All those are interchangeable words, but I should have 6 answers to this question. Okay, what do all those terms have in common? Do they have anything in common? X to the 4th. All right, here we go. So I'm going to pull an x to the 4th out in front. I'm basically going through there. What you're going to do, just subtract 4 from each exponent to write what you have left over. So this guy would be x squared minus just a plain x, and then minus just a plain 12. What you want to do from there, these questions, you're going to be able to factor a little bit further what you have left over on those parentheses there. So can you guys, and this is no Berry method or anything like that. I'm just going to start, just take that first term, drop the squared. I'm going to start that with x and x. What two numbers can I multiply to get negative 12 and add to get negative 1? So factor that. Yeah. Yes. Okay. Negative 4, positive 3. Okay, now, we're in factored form. Super quick to answer once you're in factored form. So you're just going to tell me the zeros. So if it's x plus 3, then negative 3 would be our answer. If it's x minus 4, then positive 4 would be my answer. What if it's just x to the 4th? What would my answer be there? 0. All right, now, here's the deal with that. That has an exponent of 4. So what that means is this 0 has a multiplicity of 4. So that means that one counts 4 times. Okay, now I know that's super weird, but remember I told you guys we're supposed to have 6 answers? Okay, this counts as 4, and then I have 2 more. So there's a total of 6 answers there. That's what's going on with that question. So that multiplicity helps fit that rule that we were talking about on the front. All right, this one's going to be faster. So this one is x to the 5th. So I should have 5 answers or 5 zeros or 5 roots, whatever you want to call them. And do these two terms have anything in common? X to the 3rd. All right, now left over, this is probably where I got that 49 from. You'd have x squared minus 49. So I promise we'll be able to factor this. So I have 0, x cubed. Can you think of 2 numbers? I'm going to drop the squared there and just put x at the beginning of each of the factors. Can you think of two numbers that if you multiply them, you get negative 49, but they add up to 0? If I multiply them, I get negative 49, but if I would add them, they would be 0. So they have to be the same number. Yes. One of them is a minus 7. One of them is a plus 7. Okay, we're supposed to have 5 answers to this question, right? Negative 7 is an answer. Positive 7 is an answer. And then 0 is an answer, but because it has that exponent, it counts that exponent, which is 3, so it counts 3 times. So that exponent means I have 3 zeros on 0, if that makes sense. So 1, 2, 3, 4, 5. So I have my 5 total. All right, let me try and hurry through these last two. Now, if we have a number in common, which I do in both of these last two questions, if you have an equation, you can get rid of that number, which is what I'm going to do here real quick. Everybody in part C is divisible by 2, so I'm just going to get rid of it. If I'm working with an equation, I don't have to pull that out in front, just trying to make this a little bit easier to work with. So this is really x cubed minus 6x squared plus 9x, and forgive, that doesn't affect the number of answers. My degree for this question is 3. This is a cubic, and so this should have 3 answers. All right, now I cannot get rid of a variable like I just did with the number. You're not allowed to do that, but I can get rid of the number. Do the terms then have anything in common? X. So we're going to take an x out in front. All right, left over I got x squared minus 6x plus 9, and we're going to be able to factor this. Can you guys think of, inside the little parentheses there, I'm just going to drop the squared and put x at the beginning of each of my factors. So for this guy, I got to multiply to get 9 and add to get negative 6. Think of two numbers, you multiply them together, they give you positive 9, add them, you get negative 6. Yes. Okay. Now you don't have to write this out twice, but I'm getting the same factor there, so I can squish that together. X minus 3 squared. So our actual answers, we got this x out in front, so 0 is one of our answers. And then x minus 3 would be positive 3 is our answer. But on that one, we had an exponent, so that 3, that counts twice. So that has a multiplicity of 2. And remember I told you we're supposed to have 3 answers, so 1 here, and then that 3 counts twice, so that's a total of 3. Does anybody have a question? Okay, now this last one's probably the hardest. Sorry, we're going to have to use the Berry method on this, but I do want to get rid of, everybody's divisible by 2 here on this last one, so let's just get rid of it so we're working with smaller numbers. Let's see, we got 3x to the 4th plus 22x cubed, and then minus, what is that, 16x squared. And I'm just doing this real quick because we're running low on time. Everybody here has at least an x squared, so I'm going to pull that out in front. Left over, I'd have 3x squared plus 22x, and then minus 16. And I know these numbers are kind of big, but I promise these factors are not bad. So I'm going to factor, and at the beginning of each of my factors, I'm just going to drop the squared, and I'm going to put a 3x on this one because it started with 3x squared. If I'm factoring this, so I'm just factoring this, we are going to multiply a times c. So 3 times 6, or sorry, negative 16 would be negative 48. So I got to multiply to get negative 48 and add to get 22. Can you guys think of two numbers when you multiply them? One has to be negative, one has to be positive. Negative 48, but they add up to 22. Perfect. Okay, one of them, so if you do 24 times negative 2, that's negative 48. 24 plus negative 2, that's the 22. Okay, so make one of them plus 24, one of them a minus 2. The only thing that's different here, one of these is not the real factor, and that one is going to be this 3x plus 24. Both of those guys are divisible by 3. So my real factor there, just divide both by 3, it doesn't come out in front or anything like that, it would be x plus 8. Right? 3x divided by 3 would be x, and 24 divided by 3 would be 8. The other factor, the 3x minus 2, that's totally correct. And if you want to check real quick, so x times 3x would give you back the 3x squared, and 8 times negative 2 would give you the negative 16. If you want to just check the first and last, you're usually in good shape. Now, I should have 4 answers here. So 0 out in front, and that's got an exponent, so that has a multiplicity of 2. So that counts twice. So there's 2. Then negative 8 would be third answer, and 2/3 would be the fourth answer. Is anybody having a question?